So we will observe now, this is the example 3 where we have to evaluate the integration 0 to 1, integration 0 to root of 1 plus x square, dy dx upon 1 plus x square plus y square. First tell me the order, whether it is with respect to x or with respect to y.
With y.
Yes, correct. We have to integrate it with respect to y. So I will repeat again what we are doing. Actually, if you observe the inner limits, they are in terms of variable x. So if the limits are in variable x, keep that variable as a constant. So we are going to keep x as a constant, and we are integrating with respect to y now. So first we should integrate it with respect to y. So can anyone tell me what is the integration of this integral with respect to y? Yes. Yes, anyone? What is the integration of the integral with respect to y?
Sir, I'm not sure about that. Can I speak?
Yes, you can. Yeah.
Sir, it's maybe in the form of 1 upon x square plus y square.
Yes, true. But you should convert in that form and tell me the answer then.
Sir, 1 upon under root 1 plus x
Huh?
square tan
Okay.
inverse y upon 1 under root of 1 plus x square.
Yes, very good. You are correct. So this is the important thing. Without doing a rough work, you should able to do this integration. Actually, we are treating x as a constant. Okay, now those who are not getting, already I told what you should do. You should go for rough work. For example, as already we said, the limits are in terms of variable x. So x is a constant. If x is a constant, can we take this denominator entire 1 plus x square as constant? We can take that 1 plus x square as some constant. Now we can observe it again. Y square is a variable, y is a variable, so it is like 1 upon a square plus y square. In that form we can convert it. So we're left with like integration dy upon a square plus y square, provided that 1 plus x square is a square, and integration of 1 upon a square plus y square is 1 by a tan inverse of y by a, where a value of a is square root of 1 plus x square. So we resubstituted here. So this is the integration that you have to do it without this rough work also. But if you are not able to do that, yes, you can do the rough work there. Limits of y are 0 to square root of 1 plus x square, and now integration with x we have to do it. But before that, yes, we'll replace upper and lower limit. Yes, anyone? When we replace upper limit, what will be the value? If we replace value of y by square root of 1 plus x square.
Pi by 4.
Pi by 4. Is it only pi by 4? That outside 1 upon root of 1 plus x square will be as it is, no?
Yes, sir.
And then tan inverse 1 will come, because that will get cancelled. Tan inverse 1 is a pi by 4. That's the upper limit. For lower limit, yes, this term will be as it is, but tan inverse 0 is a 0, so there is no need to write it. That's one only. If you want, you can add the step. You can write in bracket tan inverse 1 minus tan inverse 0. You can write that. And then in the next step, you can replace tan inverse 1 by pi by 4 and tan inverse 0 by 0. Okay, you will get this. So pi by 4 is a constant that will come throughout outside the integration. But can you tell me the integral for 1 upon root of 1 plus x square? How to integrate?
Sir, log.
Yes, Sanjay. Yeah.
So can I tell?
Yes.
Sir, log x plus under root of 1 plus x square.
Okay, correct. Okay, so this is the integral that you should compare it with 1 upon root of a square plus x square, or root of x square plus a square. So that is a log of, now you can write ln also. Actually ln is a more accurate term, and you can use modulus sign if you want, or you can write whatever I written here that way. So all these are correct way of writing. So this is a log of x plus root of x square plus 1, where the limits are 0 to 1. Yes, now Prajwal, you can tell me the next step. Yes, Prajwal.
Yes, so wait a minute.
Put upper limit and lower limit.
Yeah. So now, but log 1 will become 0 now if we put x is equal to 1.
Yes, log 1 is a 0, but when you put x equal to 1, are you getting only log 1 there? Is it a log 1?
No, sir. No.
Then it's just straightforward. You are replacing x by 1. So it is a log of 1 plus root 2, is it? That is for upper limit.
Yes, yes.
And for lower limit, you replace x by 0, you get log 1, and that log 1 is a 0. So no need to write it. So that is the end of the question here. We got the answer, pi by 4 log of 1 plus square root 2. Pi by 4 log of 1 plus root 2 there. Okay, any doubt here?
No, sir.
No doubt. Okay, good. So if you completed this, tell me so that we can move to the next question then. If anyone have a doubt, yes, you can ask. So can we move to the next question here then?
Yes, sir.
Okay, next one. So question is now evaluate integral 0 to 2, 0 to x square, e raised to y by x dx dy. So tell me the order first.
Dy
Pardon?
dy by dx.
Yes, dy dx. First we should integrate with y because limits are in terms of x. So can you tell me the integration? What is integration of e raised to y by x?
E to the power y by x.
Huh?
X multiplied by e to the power y by x.
Very good, that's correct. X into e raised to y by x. Actually, this integration we seen before also. The reason is in this case you will observe 1 by x is like a constant. 1 by x is like a constant, and we come across then e raised to ky dy and e raised to ky upon k. So that about the rough work there. And resubstitute the value of k as 1 by x, you get this bracket. Okay. Now put upper limit and lower limit. What should be the value of the integral? Yes. What is the value of the bracket for upper limit?
X e to the power x.
X e raised to x, correct. And for lower limit?
X.
Only x. Very good. Because e raised to 0 is there. E raised to 0 is 1. That is the end of the inner integral. Now the outer integral we have to evaluate. Which method we should use to evaluate that integral of x e raised to x?
So integration by parts.
Yes, it is a by parts. Which one should be u and which should be v?
So x should be u
u
and
e raised
e
to
to the
x
power
v.
x should be v.
Correct. Okay, good. So let me use by parts now. So for a by parts, just a minute. For by parts, I will take x as a first function into integral of second minus integration of derivative of first, integral of second. So this one is a by part. Up to here, that is a by part. And what about this integration of remaining x? What should be the integration of that x?
X square by 2.
X square
X
by
square by 2.
2. One of the simple term. 0 to 2 limit as it is, and you will observe this is where we use by parts. This term up to here, this is by part. First function x, integral of second, minus integration of derivative of first into integral of second. But yet that integration is not completed, so just one more step I will do it. X e raised to x minus e raised to x minus x square by 2, and 0 to 2 is a limit. Now put upper limit and lower limit and you can tell me the answer. Yes, if you put upper limit, yes, what will happen? If you put upper limit, what will happen here? X by 2. What will get?
E square minus 1.
E square
Okay,
minus 2.
okay, all of you are giving me the final answer, but I will write it step by step. 2e square minus e square minus 2 is for upper limit. For lower limit, minus sign, and we replace 0. This is a 0. This is a minus 1, and that is 0. So that's a minus 1. So final answer is e square minus 1. Yes, correct. The end of the question there. So if anyone have a doubt, yes, you can ask. Well, after this, one more example we'll take on type 1, and then we'll proceed to the prerequisite of a type 2 there. So once you complete, tell me. We'll move to the last question here. Last question for type 1. Yes, can I take next question?
Yes, sir.
Okay, good. So last question for type 1 is on the screen. So I will read it because it may not be visible. Question is integration 0 to 5, integration 0 to x square, x into x square plus y square dx dy. Integral 0 to 5, integral 0 to x square. So obviously the order is
dy
again dy dx. Yes, because inner limits are in terms of x. So order is a dy dx. So do it and tell me the answer. Do it and tell me the answer. I want a final answer directly. Okay. One completed. Yes. Is there anyone who completed?
So the answer is 5 to the power 6 upon 6 plus 5 to the power 7 upon 21.
Yes, is something like that only. Okay. Uh, so just 1 minute, I will come. Okay, so let I write it here. Yes, someone is on the chat. 16200, not correct, Pratham. It's not correct. Okay. So you'll observe.
Excuse me, sir.
Yes,
So is the answer in terms of fractions or do we have to write it in points?
both of it is correct. So in the exam, you can write your answer either in fraction or you can write in decimal. Both are correct. Okay. Choice is yours. Both considered correct, but your answer should be in simplified form. So first of all, we are integrating this with respect to y, but before integrating with y, I can do one thing, that x I can take inside because same term is there, so I can correct the power. X into x square is x cube plus xy square, and then as I want to integrate with y first, I'll write dy dx. So this is 0 to 5. Now integration of x cube with respect to y is x cube y, and integration is x y cube by 3, and the limits are 0 to x square dx. Now this 0 to 5 as it is, put upper limit, this is x raised to 5 minus x raised to 7 by 3. Now here some rules of indices we use, like when base is the same, we added the power. Whenever this x raised to m raised to n is there, x raised to mn, and then added the power that way. Now the last step is left. This integration with x is x raised to 6 by 6 minus,
Plus.
yeah, plus, sorry, my mistake, x raised to 8 by 3, not 3, it is 24. And limits are 0 to 5. Put upper limit and lower limit, but you'll observe x raised to 6, okay, or I will do that in the next step. 5 raised to 6 by 6 plus 5 raised to 8 by 24. Out of that, 5 raised to 6 can be taken common, and we left with 1 by 6 plus 5 square, that is 25 by 24. And so simplified answer can be kept like this: 5 raised to 6 into, this is a, if you take LCM, this is a 29
Take 6 common.
by 24, with 6 common. Okay, that also, okay, you can do it. But this is one of the way to write the answer. Calculators are with you, or calculators are allowed in the exam, and you can simplify this on calculator. You may get 1875 point something, 1875 point something. Okay, so that also you can write it. It is not 1880, Pratham. Okay. That answer in the textbook is wrong. In the answer textbook answer is 1888 0. That is a textbook answer. That is their calculation mistake is there. You can cross check later on. 18875 something is the answer. Okay. Or you can keep this as answer. No need to go further. You can keep this as answer also. You can get the full marks there. Okay. Any doubt?
No, sir.
No. Okay. So that about your type 1. Type 1 is one of the simple type where the limits of double integral given, just we have to integrate it one by one. Evaluate the innermost integral first and then the outer one by one there. And the prerequisite is that 12 formulas we discussed already there. Okay. Next one. Now here we are going to see some prerequisite curves that we require in a type 2. Okay. Remember, none of the question will come in the exam like trace the following curve or draw the following curve. So that will not be a question. It is just a prerequisite. We have to draw. Yes, we have to draw these curves, but we have to draw like a rough curves only. Okay. Just you see the equation, you should draw the rough curve there. And which curves we want? I will tell you which curves we are going to see it right now. Straight line, parabola, ellipse, circle. Okay, so these are the main curves that number of times you come across. Then exponential curve, oblique hyperbola, and maximum that asteroid is there that may be new to you. So these are the curves that we have. So I'll show it one by one. So these curves that you should remember with equation. Even though you don't know the curve tracing, you can remember these curves there. So the first thing, yes, we are interested in Cartesian curves right now. This is the Cartesian curves, y equal to fx and f of xy equal to 0. So when the equation is in terms of x and y, that is a Cartesian equation. And this is the explicit form y equal to fx, and f of xy equal to 0 is implicit form. So equation may be in any of that form. You should know the curve there. The first one, if I say y square equal to 4ax, yes, anyone? What is that curve? Y square equal to 4ax.
Parabola.
Which parabola? Which parabola again?
Standard parabola.
Standard, but right hand side is the more appropriate answer. That is the right hand parabola. When you draw it, you draw on the right hand side of the y-axis there, and you get that y square equal to 4x. And if I say x square equal to 4ay,
Upward side parabola. Upward parabola.
yes, upward parabola. That's correct. So there are few rules in curve tracing actually. The first rule says it is a symmetry, and the symmetry is checked with the power of x and y. Whenever there is an even power of y, powers of y are even everywhere in the equation. Like y square equal to 4x. Y square equal to 4x. When even power of y is there, the curve is symmetric about x-axis. And you can say it is a right-hand parabola. So the parabola will be right-hand there. So this one. This y square equal to 4x, right-hand parabola. Similarly, if there is only even power of x, there, like here. So it is symmetric about y-axis, and that is upper parabola then. This is the upper parabola. Okay. So this is these are the rules, but no need to remember the rule also. You can remember the standard curves only. We are interested this rough nature of that graph only. Then we have the curve like xy equal to 1. Yes, what is the name of this curve? Anyone knows? Xy equal to 1. Don't know. This is known as oblique hyperbola or rectangular hyperbola. Okay. And x cube equal to y. These curves are symmetric in opposite quadrant. So you should remember this nature of the curve. This is y equal to x cube graph. Okay, y equal to x cube graph is this one. So we have the graph in first quadrant and the graph in third quadrant. Just you should remember the nature. And the last here, xy equal to 1. This is xy equal to 1. The graph is in the first quadrant and the graph is in the third quadrant. First and third quadrant, the graph is there for xy equal to 1 and y equal to x cube. Okay, so just you see the equation xy equal to 1, you should able to draw this curve. You should able to draw this curve, whatever drawn in the blue color there. So that is main the graph. This dotted line is actually showing this graph is symmetric about line x equal to y also. Okay, that one. So that about first four curves. Okay, the first four curves. Then we have a straight line. You can see the straight line here. The first one is x equal to y. This is x equal to y. X equal to y is
Excuse me, sir.
yes.
Can you please repeat previous point?
No, just I'm not saying you have to understand this rule. I'm saying just you have to remember the curves now, because curve tracing is one of the bigger topic. It is exactly it will take 10 to 15 hours. Okay, there are a number of points: symmetry, point of intersection, then asymptotes, tangents. Okay, region of absence. So these number of points you have to decide, and then you have to draw the curve. So that is not a part of our syllabus. So just I'm giving you the hint that which part we require or which curves you have to remember. Just like I said, parabola. When you come across parabola, you should know whether you have to draw it on right hand side parabola or upward parabola. That's only these two parabolas we require: right hand parabola and upward parabola. Similarly, you should know that xy equal to one rectangular hyperbola, and you should know y equal to x cube curve. Okay. Now I'm saying about straight line here, x equal to y. When this x equal to y is there, this is straight line passing through origin. So whenever there is a straight line, you can remember to draw a straight line, we require minimum 2 points. So x equal to y, we can take 0, 0, 1, 1, 2, 2, 3, 3. That are the points, and you can draw a line passing through it. But when the straight line comes like this, y equal to x plus 2, y is equal to x plus 2. Put x equal to 0, you get y as a 2. Put x is 0, y is 2. So you get this point. Okay. Then you put y equal to 0, you get x equal to minus 2. You get this point. And then you can draw a line passing through that 2 points there. I hope you are getting how to draw a straight line. X equal to y or y is equal to x plus 2. To draw these lines, you can take minimum 2 points in the plane of that line, and you can draw that line then. Okay. And the last set of the curves then. So here is a last set of the curve. This is the asteroid. This curve is asteroid. This is also the asteroid. So it is this equation little bit similar to the circle. The circle have the power as x square plus y square equal to a square. But here x raised to 2, instead of x raised to 2, it is x raised to 2 by 3 plus y raised to 2 by 3 equal to a raised to 2 by 3. The name is hypocycloid or asteroid. That is the name of the curve. And you should remember the curve because we are not going in the curve tracing. So exactly at the same point it intersects A0, 0A. This is minus A0. This is 0 minus A. If we have circle, the circle will look like this. This will be the circle. This is the circle. But exactly at that 2 point, instead of outer, this is a convex arc, it is a concave arc there. That's the difference in circle and asteroid there. So just you have to draw the concave arcs at 4 places. So you get asteroid there. So this is the asteroid for x raised to 2 by 3 plus y raised to 2 by 3 equal to a raised to 2 by 3. But if it is x upon a raised to 2 by 3 plus y upon b raised to 2 by 3 is equal to 1. Now this equation is similar to the ellipse. It is like x square upon a square plus y square upon b square is equal to 1. So that's the ellipse. So the ellipse will look like this. And in that ellipse, if you draw, instead of convex, if you draw that concave, you get this asteroid. Okay, this is the asteroid again. So I'm not giving you the curve tracing part. I'm just telling you to by heart remember these curves, because we don't have that much of a time in going in the curve tracing. Okay, and no need also. Don't waste your time in learning the curve tracing. Not required that much. Okay, if you have enough time, then you can go through it. But I will tell you these only the basic curves we require, and you should be able to remember these curves. This is asteroid, this is also asteroid, and this is the ellipse here. This is the equation of ellipse that written there. Okay. Again, these are the few lines you should know. Can you tell about x equal to h is a line parallel to which axis? X equal to constant is a line parallel to
Y.
correct y-axis, and y equal to constant is a parallel to x-axis there. Okay, so that about the straight lines you should know, because we are going to draw these lines, we are going to use these lines. in the type 2 there. Okay, I think that is, yes, one last curve is there. Exponential curve, e raised to x. E raised to x is increasing curve. It is increasing, exponentially increasing. So whenever e raised to minus infinity tends to 0, so this side it is tending to the 0, because e raised to minus infinity is a 0, but e raised to infinity is infinity. So you'll observe that is exponentially increasing, and this curve is intersecting at y-axis at this point 0, 1. Why? Because when y is equal to e raised to x is a curve, and if you put x equal to 0, we get e raised to 0, y is equal to e raised to 0, and e raised to 0 is 1. So 0, 1 is a point of intersection with y-axis, and that is the y equal to e raised to x curve. So these are only the curves. These are only the curves that you should remember. So I will summarize the list of the curves that we seen. So let let I write the name of the curves that we require. The first curve just we have here, which is e raised to x only. Okay. The next curve that we have, this is y equal to e raised to x is the first curve. Next we have circle, x square plus y square equal to a square, or ellipse. Okay, or ellipse you should remember, that is a second. Third is asteroid, which is x raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 2 by 3. That is a third curve. Okay, that you should know, which is a asteroid, third curve. Fourth is a straight lines, say x equal to y, x plus y equal to 2. This type of the straight lines you should able to draw. Okay, x equal to constant, so x equal to 5, y is equal to 3. So these type of the lines you should able to draw. Fifth, parabola, y square equal to 4x and x square equal to 4ay. So this is the fifth set of the curve that you should draw. Yes, anything we left? Anyone? Yes, there are oblique hyperbola. First of all, xy equal to 1 and y equal to x cube. So this 6 set of the equations and their curves you should know. Okay, so whenever I give you the equation, say y equal to x cube, quickly you should able to draw this curve in a first and third quadrant. Got it? So these 6 curves you should go through that in the PPT again. Okay, you have the PPT. In the next session we'll start type 2 example. That time I will ask you about this, means whenever we come across in the numerical, we come across this equation, and then you should able to draw this rough sketch. For example, when I say draw the curve y square equal to 4x, you should able to do like this quickly. Even power of y is there, so it should be symmetric about x-axis. Is the right hand parabola. You should able to draw this curve. That's one. This is the rough nature. That is a rough nature for y square equal to 4x, and that thing you should able to do it in the next class there. Okay, so you have